Okay, there we go. Kate, do you want to close that door? Please. All right. So, inequalities. Okay, so, all right. First thing about inequalities. Okay, inequalities means two things that are not equal. Okay? Okay, this is graphing inequalities. Okay, so when we graph inequalities, we're talking about two, well, first of all, we're going to have a variable, okay? And we're going to, remember, what are some signs for inequalities? Greater than or less than, what else? If I have this and this underneath, what does that mean? Or equal to, right? Okay. This or this also means. Okay, so this is just greater than or less than. And these are greater or less than. Well, I shouldn't do that. I'll make it an arrow. Or equal to. Okay? So somebody, let's see. Allison, give me a number.
2.
Okay, if I did this, what is x?
Something higher than 2.
Is there one answer for x?
No.
X can be anything, as long as it's what?
Higher than 2.
Greater than 2, right? What about this? What is x?
2. It could
Lily?
be 2 or bigger than 2.
Can be 2 or anything above 2, right? But it can include 2, right? Okay. All right. Now, when you have, if you remember, when we graphed things, okay, everything that we graphed, whoops, sorry. When we graph things, what do we have to put what form were, everything you graphed last week, what form were those equations in? Anybody remember? Slope-intercept form, right? Okay. So if we have something like this, y equals mx plus b, okay? If this is replaced with this or this or this or this, okay? We graph all of these the exact same way, okay? So when we have an equation that is replaced with one of these, it looks that way, we still graph it the same way. In other words, we're going to treat it just like a slope-intercept form. We look for what? What do we look for first if we're graphing in slope-intercept form? The y-intercept. We look for the y-intercept and we look for the slope, okay? And then we graph it, okay? Now, a little bit, can I erase what's in orange over here? Can I erase this part? Okay. So what we look for first, okay, when we graph these, there's a lot of steps involved here, okay? When we graph these, if the equation has this or this, okay, that means that we're going to use a dotted line, okay? If it is this or this, that means we're going to use a solid line, okay? Now I'll explain more about what that means in just a second. Okay, so let's take a really simple equation, okay? I'm sorry, not equation, I said the wrong thing. Let's take a really simple inequality, okay? Let's say I've got y is greater than 2x plus 3. Okay, remember, treat this and this just like its slope-intercept form. Okay, is y by itself here? Yeah, we're okay. So can I identify my y-intercept from this? I can. What's my y-intercept? 3. Okay. So my b equals 3. And what's my slope on this equation, or this inequality? 2, and I have to represent that slope as a fraction, so what's that going to be? 2 over 1. Does everybody understand that? Okay, that's not new, is it? Okay, so 2 over 1. Now let's go to our graph, and let's go ahead and put these values in. Okay, I have a y-intercept of 3, so that's going to be 3 on my y-axis. I'm going to put a point here. And what was my slope? 2 over 1. So from here, I'm going to go where? Up 2 and over 1. Okay. So far, everybody understands what we just did, right? Okay. All right, now, the next part, first of all, was this one of these two or one of these two? Was this just greater than or less than, or was this greater than or less than or equal to? Yeah, so I'm going to use a dotted line. So when I make my line connecting these, okay, I'm going to use, I don't know if this has, I think it does. Yeah, I'm going to use a dotted line, okay? All right, so go ahead and graph that, just like that, okay? And now, when you have an inequality, okay, if I was going to find the solution set, okay, remember when I said x is greater than 2? Okay, and I said, what is x? And you could give me any number as long as what? As long as it's greater than 2, okay? So x can be any number greater than 2. Well, when we come up with our solution set, it can be many, 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 many different answers, okay? But what we've got to do is we're going to shade the side. We're going to shade a side that shows all of the side that the answers are on, that make that equation true, okay? Because there's two sides to this side, there's two sides to this inequality, okay? There is this side and there's this side, okay? So when we are finding out what to shade, okay, we're going to use a test point. Okay, you know what, let me go through the steps here, okay? Step 1, graph the inequality. Okay, step 2, we're going to shade the side that makes the inequality true. Now, the way you do this is by using a test point, okay? Do you remember when we were graphing, when we were doing functions, what was the easiest value to put in either your x or your y? 0. Thank you. When you put a 0 in there, it makes it really easy, okay? So we're going to use a test point of 0, okay? So use 0 as a test point. Actually, instead, we're not even going to call it 0. We're going to call it, because these are going to have a solution set. So we're going to have 0, 0 as a test point, okay? So if we go to our equation, our inequality, okay, where is 0, 0? It is right here, right? Everybody agree? Okay, now let's look at our inequality. If I replace this y, okay, I have y is greater than 2x plus 3. If I replace the y with a 0, and I replace the x with a 0, okay, what is 2 times 0?
0.
What is 0 plus 3? Okay, is that true? What we just figured out there, is that true?
No.
0 is not greater than 3, okay? So what that means, when we go to our graph, the side that contains the test point, the side of this line where the test point is, that side is not true. Anything over here, any point on this side of this line is going to prove to be not true if we plug it into that inequality. What do you think that means on the other side?
It's true.
Everything on the other side would make that inequality true or valid, okay? So what we do is we take the other side, we go to the other side, and we shade this side. And you can just kind of put lines, okay? And any point that I choose that's over in that, on that side of the line, any point that I choose is going to make that inequality true, okay? Let's try it. Christy, no,
You said that's shaded on
the side that
that
makes it true.
shaded is correct.
Yes.
Okay.
So give me a point. Christy, pick any point on this side of the line. Anything over here.
6, negative, wait, can it be negative?
It has to be negative if it's
Oh,
over
yeah.
here.
-2,
So -2 what?
6.
6. -2, 6. Okay, let's plug that in and let's see if it's right. Okay? If I take my inequality, I have y is greater than 2x plus 3. And what did you say? -2, 6. Okay. So that means my y is 6. My x is 2, is -2 plus 3. What's 2 times -2? Okay, is 6. What's -4 plus 3? Is that true?
Yes.
Yes, it is. Anything that I pick that's in this shaded region is going to be true. Anything that I pick over here is not going to be true.
So we shade the side that's true.
You shade the side that's true. Okay? Does that make a little, it's kind of complicated, but does that make sense what we did? Yeah? Let's try another one. Okay? Let's try another one. All right. Can I erase all this, guys?
I need the flash bomb up again. If you're just erasing the right. No, just the one else.
Okay. I'll erase all of this stuff. Okay.
And so 6 is equal to -1?
6 is greater than -1.
Oh, as long as it's greater.
As long as it's true.
Okay.
As long as when I look at that inequality, once I've plugged those values in and simplified it, as long as it's true, then I'm in good shape.
So will we always, if it's like lesser than the number on the right, will you always shade to the left?
Not necessarily. It's the side. When you put that test point, if it's true on that side, you shade there. If it's not true, you shade the other side. Okay? Let's look at one. Let's say I've got this. Let's say I've got y is less than or equal to 1/3 x plus 1. Okay. What do I need from this to graph? What do I need? What do I need? Y-intercept and what?
Slope.
And slope. Okay, what's my y-intercept? Everybody, what's my y-intercept? 1. What's my slope? 1/3. Do I have enough to graph? Okay, so let's go graph this. Y-intercept is 1. My slope is 1/3. So up 1 or down 1? Up 1 over 3. 1, 2, 3. Now, on this one, what did you notice? This is not just greater than or less than. What is this one? Or equal to. So if it's or equal to, am I going to have a solid line or a dotted line? Solid line. Okay? So if I have a solid line, okay, just a second. Okay, I have a solid line right there. Okay? Now let's go back and let's plug in. Okay, we graphed the inequality. We did step 1, right? Now step 2. Shade the side that makes the inequality true. Well, by using a test point. So what test point are we going to use every time? 0, 0, unless it runs through 0, 0. Okay, none of the ones I gave you run through 0, 0. If it does, you can use any test point. You could use 1, 1. You could use -5, -5. It doesn't matter. A test point will prove whether that inequality is true on either side of the line. Does that make sense? So let's use 0, 0. If I use 0, 0. Okay, if I replace this with 0. 0 is less than or equal to 1/3 times 0 plus 1. 0 is, what's 1/3 times 0? That's a tough one. What's 1/3 times 0?
0.
What's 98/3 times 0?
0.
Anything times 0 is what? 0. What's 0 plus 1? Is 0 less than or equal to 1?
Yes.
Is it? Is 0 less than or equal to 1?
Yes. Wait, oh.
Is 0 less than or equal to 1? Don't overthink it. Okay. Now, which side is that on? Is it on this side or this side? This is my test point. If it's true, I shade the side that has the test point. Okay? So what side am I going to shade?
Bottom side.
So everything down here is going to be shaded. Okay? If the test point, the side, okay, there's two sides to this line, right? One of them contains the test point, the other side does not, right? When I put that test point in, if it's true, I shade that side. If it's not true, I shade the other side. Does that make sense?
Like the side behind or on top of
The side that has the test point in it. See the test point's right here? If it's true, I shade this side. If it's false, I shade the other one. Okay? Yo.
If it's, does that apply to each time? Like, it's always that side? Is always the bottom? It's gonna be.
Well, it may not be the bottom, because if my line, let's say my line was down here, okay? It it depends. If the test point, when I plug it in, if it makes it true, I shade the side that has the test point. If it's false, I shade the other side. Okay?
Oh, the side of the line.
Mm-hmm.
Okay.
Okay, does this kind of make sense a little bit?
Yeah.
You want to do one more? Let's do another one. Okay. All right. Okay. Let's say I got this equation. I've got y is greater than negative 3x minus 2. Okay. What do I need from this equation? What's the first thing I need? Samir, what do I need from this equation?
You need to find the mass of slope.
The y-intercept. Yeah, don't need the mass. What's the y-intercept?
It's 2.
What?
Negative 2.
Negative 2. Caden, what's my slope?
-3 over 1.
Negative 3. You guys agree? Okay, can I graph this? All right, let's graph it. Well, my y-intercept is negative 2. How do I graph negative 3 over 1? What am I going to do? Go down 3 and over 1. Okay. Now on this one, this is going a different direction. Okay. Do you think this changes anything? No. And should I make a solid line or a dotted line? Dotted, because this is just what? Greater than, right? Greater than or less than. Okay, so I'm going to have a dotted line just about like that. Okay. What's my next step? No, what's my next step? Plug in my test point. Okay. So if I plug in a 0 here, use my test point of 0, 0. Okay, that says 0 is greater than negative 3 times 0 minus 2. What's negative 3 times 0? 0 minus 2 is what? Is 0 greater than negative 2?
Yes.
Is it? Would you rather have $0 or owe me $2? You'd rather have $0, right? Okay, so because that's true, which side contains the test point? Should I shade this side? No, which, holy, that's hard to say. Which side should I shade? Wow. The side that contains the what? Test point, good. So I'm going to shade this side. Okay. Does that make sense?
So if it's not true, we shade
Shade the other side.
the others.
Yeah. If this was when we plugged this in, if this made it untrue, we would shade the other side of the line. The side that does not have the test point on it.
If it was true, we'd shade the side that does not.
If it is true, we shade the side with the test point, which it was. If it's not true, we shade the other side.
Okay, it's not true.
That was true.
Okay.
Yes.
So what's with the dotted line and the solid line?
Okay, the dotted line, the solid line, anything on a dotted line, if it's on the line, it's not gonna be true. If it's a solid line because it's or equal to, anything on that line means it's true. If it's graphed exactly on that line. Everything on this has to be completely on this side of the line. But if it was solid, then it could be on that line and still be true because of the or equal to. What?
Since this one's true, if it wasn't true, we would put it on the other side.
Other side.
Touching the line.
Correct. Okay? All right.